Hello good people, I'm going to present a brief introduction to covalent compounds. What are covalent compounds and how are they different from ionic compounds? To answer that, I'm going to take a step back and briefly revisit ionic compounds. Ionic compounds are a result of bonding between a metal and a non-metal. Metals will lose electrons to become cations, and nonmetals will gain electrons to become anions. Ultimately, it is the cations and the anions that will give the ionic compound. In terms of Lewis dot structures, I might represent the whole business like so. Here is my sodium atom, and here is its valence electron. Over here to the right, I have a chlorine atom with 7 of its valence electrons. Sodium will lose or donate its valence electron to chlorine, and as a result, I will end up with a positively charged sodium cation and a negatively charged sodium anion. Let me draw in the valence electrons as well. So the anion has 7 of its original valence electrons, but it has also gained the electron of sodium. The formula of this salt, sodium chloride, would be written as NaCl. Note that we do not write it as Na-Cl. So this is not how we write the formula of sodium chloride. The above method is correct. A line between two atoms suggests a sharing of electrons. That is not what is happening here. However, that is exactly what is happening when it comes to covalent compounds. Let me get rid of this and bring in a definition for a covalent compound. Covalent compounds are a result of electron sharing involving two or more nonmetals or metalloids. How can I represent this sharing of electrons using Lewis dot structures? Here is my hydrogen, and a hydrogen has a single valence electron. And over here to the right, I have a fluorine. Fluorine has 7 valence electrons, so let me quickly draw those dots in. Here we are, 7 dots. And now, unlike in ionic compounds, electrons will not be lost nor gained. They will be shared. I'm going to grab the hydrogen and bring it in closer, something like this. Recall that all atoms gain stability by having the electron configuration of a noble gas. From the point of view of hydrogen, it has a pair of valence electrons, just like helium. From the point of view of fluorine, it has 4 pairs of valence electrons, just like neon. So the sharing of electrons allows both atoms to achieve a stable electron configuration. The electrons that are shared are called bonding or shared electrons. The other pairs of electrons, so these 3 pairs, are known as the lone pair electrons. When we write the actual formula of this compound, we use a line between atoms to indicate the bonding electrons. So this compound could be written as H-F. The dash, or the line between the hydrogen and the fluorine, represents a pair of shared electrons. Note that in most cases we do not draw in the lone pair electrons. That being said, there are cases where we do draw in the lone pairs, because they help us explain the shapes and reactivities of molecules. More on that later. In summary, unlike ionic compounds where electrons are either donated or accepted, covalent compounds arise when we have a sharing of electrons. This sharing of electrons allows the atoms of a covalent compound to have stable electron configurations. That is all for now, and I will see you on the flip side.